Cool. All right, so hopefully everyone can see my screen now. Yeah, so like I said, today we're talking about pass by references versus pass by value. I think it's actually one of the more interesting topics that we're going to cover in this bootcamp curriculum. And the reason why is because it's once again one of those things that's very subtly been a part of every piece of JavaScript that we've written so far. And it kind of makes sense if you don't think too much about it. But the more you think about it, the harder it gets. And so I'm really kind of glad to be able to talk about it because once again, you will see this in almost every facet of JavaScript that you use going forward. Just make sure. So Sagar, no. So no, we're not going over the Sudoku project. After the lesson today, I'm actually going to open the solutions for it. If you want me to go through your code and review it, feel free to send it to me on a one-off basis. Otherwise, on the Sudoku project, we will also have the solutions kind of posted like we do for traditional workshops too. So you do have solutions handy, whether it be through me or the solution video, but we won't be dedicating any class time to it. Okay, cool. So let me just get underway here. So yeah. Okay. So really, like for today's class, all we're really going to be talking about is actually this very simple idea of how do I copy or how do I move a particular variable. And so as you can imagine, it sounds like a very simple ask, but there's a deep level of complexity to it. First things first, before we talk about moving values, let's do a really quick recap on the main types of values that we've seen so far, right? So every data value or data type that we've seen so far in JavaScript, we've been able to put into one of two buckets. Either they're primitive, so which means that they are not changeable, i.e. once I create it, that value is what it is. So things that fall into this category include numbers, booleans, and strings, which are the most common ones that we've been using. And we've contrasted that with what we call complex values, right? So complex value types are things like objects and arrays, where once we create it, we can actually go back and edit it if we want to, without having to recreate the entire thing over from scratch. And so when we think about primitive values, so those are the two data types. And when we think about how we copy each one of those, we've actually been seeing some very inconsistent behavior between those two types, right? So here's an example. Let's say on line 2 there, I create a value called British city and I set it equal to the string York. On line 3, I create this variable called American city and I set it equal to the variable British city, right? So hopefully everyone can kind of really quickly follow along this chain, right? American city equals British city and British city equals York. Therefore, we can say, you know, with a high degree of confidence that logically the value of American city should be York. And so then if the value of American city is York on line 5 there, I'm actually saying, hey, let's reset the value of American city to whatever it is now plus prepended by the string new. So when everything's said and done, if I console log out British city and then I console log out American city, one thing you'll notice is that American city becomes new space York, right? Because it's what I overwrote it and created on line 5 there. But notice how British city on line 2 there, it did not change, right? And the reason why it did not change is because essentially what we're saying here is that, hey, when I set on line 3 there, when I set American equal to British city and British city is equal to York, it looks like when I start editing American city on line 5 there, what I'm doing is I'm changing what American city is, but I am not changing what British city is. However, let's then contrast to how this will look if I was to do a very similar process but with an array. Here on line 2, I now say British city is equal to an array with one value, the string York. On line 3, I have this variable called American city. Once again, I set it equal to British city, which is equal to this array with a string called York. Now, on line 5, just like in the previous example, I am changing American city. In this case, I am unshifting a value, the string new, into the array. And just to recap for everyone, unshift means add to the beginning of the array. Okay. Now, if I was to console log out British city and console log out American city, you'll notice that for American city, it kind of makes sense, right? Our initial value on line 3 there was this array with the string York, and on line 5, we added the string new to the beginning of the array. So therefore, the American city is now an array with two strings, new and York. However, what's different about this example than the previous example is that if we look at British city, notice how British city actually also is an array with two elements, right? Or in this case, two strings, one's new and one's York, right? And this is actually a pretty powerful concept because in the previous example, we saw that when I tried to do this with a string, when I changed the copy or when I changed American city, British city was not changed. Here, when I change American city, whereas the original value was an array, the original value was also changed. And so that distinction or that difference is basically at the crux of today's lesson here. So the question now is, why do primitive values and complex values behave differently? And the short answer is because we're going to think about it. So there's a few ways for us to think about it, and I'm just gonna walk us through this really quick. But obviously, feel free to jump in with any questions. I'm just moving the screen a little bit. Okay. So whenever you assign a primitive value, so once again, that's a number, a string, or a Boolean, what happens is that variable stores not that value exactly, it stores a copy of that value. So if I was to do this in graphical form, here on line 4, I have this line of code that says create the variable first and assign to it the value 20, okay? And so on line, I guess, on the bottom right hand corner of your screen, right? In the first line there, we have this first, and it's a variable, and it's pointing to this value called 20, okay? That's the graphical representation of line 4. However, on line 5, if I say, hey, do you mind changing the variable first value to 30? What that does is now we're actually going to redraw the arrow. And instead of saying, hey, you're still, or rather now what we're saying is, hey, you used to point to the value 20, but now you point to the value 30, right? And so it's almost like we erase the previous line with the value, and now we're having the variable first act as a new pointer or point to a new value, in this case 30. On line 7, and this is very crucial here, notice how we have a variable called second, and we also set it to the equal to the value of 30. But if I look on the arrows in the bottom right hand corner, you'll notice how the variable second also points to a value called 30. But those two values there, between first and second, even though they're both equal to 30, they both are pointing to different versions of 30. Okay? As in, there's nothing that connects the variable first to the variable second, even though they both have the value of 30. Think of it another way. If you go back to the first line of this page, right? What each variable doing is each variable is storing its own copy of that value. So in this case, both the first and the second variables are storing its own copy of the value of 30. And the reason why that's really critical for us to kind of keep in mind is because on line 8 there, right? When I increase the variable second by 1, that's what second plus plus is doing. The variable second now points to a new value 31, but the first value does not change, right? The first value is still pointing to 30. Okay, so we're going to go through a few examples of this. This is just, I think, one of 3. But just keep in mind that just because two variables are pointing to the same value, it does not mean they're connected. And if two variables are not connected, it means whatever you do to one of those values does not impact what happens to the other value. So in this case, first and second are both equal to 30. Whatever I do to first will not affect second, and vice versa. Cool. So let's go through another example, right? Once again, we go back to our classic, the variable first is equal to 20. But now, here's where we see the phenomenon that we observed when we tried to use British city and American city, right? So in this case, the variable first is pointing to 20, and on line 2 there, we create this variable called second, and we set it equal to first. Remember the lesson from the previous slide. Whenever we assign a primitive value, right, so a number, a string, a Boolean, etc., whenever we assign a primitive value to a variable, we always store a copy of that variable. And so here, even though the first line is asking us to create a variable called first and pointing to a value called 20, on line 2, we create a variable called second, and we're pointing it to the value of first. And what is the value of first? The value of first is a primitive. It's a number 20. And so therefore, the variable second points to the value 20, but it is pointing to its own copy of the value 20, right? That's what we mean when we say that it stores its own copy. It means that this variable second is pointing to its own copy of the value 20. And once again, the reason why this is important is because now if I try to play around with or impact one of those two variables, in this case I'm adding 1 to my second variable, it doesn't impact my first variable, right? And this is consistent with what we thought was what we saw with our American city versus British city example. Even though even though British city was equal to York, and American city was equal to British city, what we now know is that when we said American city equal to British city, we weren't pointing to that copy of British city. We were doing this because we were creating a copy of the value of British city and assigning it to American city. And that's why when we changed American city, it did not change British city. Okay, so once again, the key lesson here for you to know is just that whenever you're setting a variable equal to a primitive value, that variable will always look to see what the primitive value is, make its own copy of it, and point to that. Right. So from that point forward, whatever you do to that primitive value will not impact, kind of the variable that it was copied from, if you will. And that's very different than what we see with complex data types, right? Because if I now do the same exercise with complex data types, what you'll notice is that when I try to store a complex data type, so in our case an array or an object to a variable, I actually don't make a copy of that value. What I do is I actually point to that specific version of the value. Okay, and I'll talk about what reference is in 1 second, but let's just make sure the idea here flows. Here on line 7, we have this variable called first. We set it equal to a reference, or in this case, we can think of it as an address, right? Almost like the place in the computer's hard drive, or the place in the computer's memory where a piece of data is being stored. And we're saying the variable first points to this address, which points to the value of the array 10, 20. Now, if I add 30 to first, because first is a complex data type, that means I am able to change it. Notice how now my reference, my address did not change, right? It is still 0x001, but the value of this variable first now, it's no longer an array with 2 values. We've now added 1 more value to this array, so the value is 10, 20, 30. Okay, so this just shows that for complex data types, when we add values into it, we're not changing where the value is located. We are literally just updating that value with whatever our new value is. If we now go back to the example that we were doing earlier with first and second and primitive data types, and we do the same thing now. This one I think everyone is pretty comfortable with by this point. This just goes to show that if I create 2 variables that is equal to the same value, or sorry, the same complex value. In this case, the analogy I always give is that if I buy a Toyota Prius and my friend buys a Toyota Prius, even though we both bought the same model of car, even though we happen to bought the same car, like they are distinctly different cars, right? And so the same idea applies here. Even though for the variables first and second are equal to the same values, those values they happen to be the same, but they have no connection to each other, right? And that's why if I look on the bottom right hand corner of my screen for the 2 variables first and second, notice how each of those variables point to a different address, right? Because the value that they're storing, even though it has the same value, those 2 are located in different places in the computer's memory. And that is also why, just like in the earlier example, if I have 2 variables or pointing to 2 values that have no connection to each other, well, in that case, and if I change one of those values, it will not impact the other value. So in this case, if I add 30 to my array second, to my variable second, it does not impact the value of the variable first. Okay. And so, last but not least, let's now kind of complete our little model, if you will, right? So we go back, we have our variable called first, we go to 10, 20. What happens now when on line 3, I do this thing where I say, hey, let second equal first, right? And so the problem, well, not problem, but the interesting thing here now is, if this was primitive, I can pretty comfortably say, well, I'll just make a copy of first and then store that value into second, right? But because this is a complex data type, we do make a copy, but what we do is we don't make a copy of the value. We actually make a copy of the address, right? And so if I look on the bottom right hand corner of the screen, I still have my two values, first and second, right? And when I set second equal to first there on line 3, what I'm really doing is I am setting the variable second to point to the same reference or the same address as the value for first. And so if I think of this, in a very kind of real world setting, right? If I have, if person A gives me an address for somewhere in the city and person B gives me the same address in the city, well, it means that in that case that those two addresses converge to the same location in the city, right? Because the addresses are the same. Same exact ideas here. Because the reference for first is 0x001, and when I say let second equal to first, the computer goes through, checks the value of first, and says, oh, it's a complex value. So rather than let me copy the array 10, 20, let me copy the reference or the address for first. In this case, it's still 0x001, and let's store that as the reference for second. And so if I follow the chain for the variable second now, right? Second points to the same reference address as the variable first, and so that just means definitionally that then second also eventually points to the same value as first. And so in this diagram here where I have the variables first and second both pointing to the same reference, which then points to the same value, if I change second, well, that means I also change that value for whoever else was pointing to it, which in this case includes the variable first. And so now we see an example in complex data types where whatever I do to one version of the value does change anyone else who may also have been pointed to this value. Just remember, once again, we avoid this situation with primitives because in primitives we would just make a copy of the value and store the and store that value in the newly created variable. Here, what we're doing is we're not copying that value, we're actually copying that address and then having the new variable point to that same address. Okay. Let me go back here. Okay, any questions up to here? Everyone's feeling good? This makes sense? Anyone? Can I get a yes from someone just so I know that people can hear me and that this makes sense to folks? Yep. Um, so the idea here is that if I have two variables and I know that they're pointing to the same reference or the same address, then they by definition have to be pointing ultimately to the same value. Right? So it's like, like it's almost like saying like, and maybe this is where you're getting at, is if I go back to the idea of the analogy, it's like if I meet two people at a party and one of them says, oh, I live at 123 ABC Street in New York, New York, and I meet someone else and they say, oh, I also live at 123 ABC Street, New York, New York, then it means by definition they have to be living in the same place, right? And so whenever we set variables equal to one another and those values of those are complex values, what we're saying is, hey, look, on line 3 there, when I say second equal to first, the idea is now second and first have a relationship going forward, right? Where they're both pointing to the same values. And so when I change the value for one of them, then I also change the value for the second one. It's like saying like if once again, if I go back to the analogy of the two people living in the same place, if one of them says, oh, hey, can you come by tomorrow and paint my house blue? And I do, then it means that the house was also painted blue for the first person who lived at 123 ABC Street. Right, so we're just kind of establishing this connection between these two variables, that whatever happens to one has to happen to the other. Does that make sense or answer your question? Perfect. Cool. All right. So this is pretty much the crux or the main concept we're trying to get you comfortable with, is this idea that the way that we copy and pass around primitives is different than the way we copy and pass around complex values. So let's take a look at another example here, right? One of the things we talked about when we did our section on arrays is this idea called slice. Well, what we said was what slice does is slice creates a new copy of the value, right? And we didn't really exactly spend too much time talking about what that means, but hopefully now in retrospect we kind of see why slice is very powerful, right? Is because inherently on line 1 here I have this variable equal to first and it's equal to the array 10, 20, right? And that has its own reference. What if I want to make my own copy of first so that I can do things and play around with it, but I don't want to mess around with first? Well, the way to do that is make a copy of an array, and the easiest way to make a copy of an array is with the slice function. In this case, just keep in mind that when you call slice without putting in any arguments, what it does is that makes a copy of the entire array. So here on line 3, on the right hand side of the equal sign, the first thing we do is we say first.slice. And that basically says go to first, get the values of that array, and then let's make our own version of that array, right? And making our own version of that array means we happen to have the same value, but we're going to store that value somewhere differently. In this case, we're storing as 0x002. And now let's set that reference or that address to this second variable. And so now if I change second, once again, just looking at the table on the bottom right hand side, we'll notice that how after I did slice and after I made a copy of the array, my first and second variables no longer have any ties to each other. And so whatever happens to second will, so that just means that whatever happens to second will not impact whatever happens to first. Okay, and so if I do have a complex data type, but I want to make sure and I want to make a copy of it to kind of play around or do my own testing with, then slice becomes the way to do that for arrays. Yeah. So you might be asking at this point, well, when do we ever pass these values, right? This seems like a nice idea in theory, but when do we actually use this? Well, we use this all the time. And in my mind, the most clear examples of when we do this is when we ever call a function. Right? Here I have on line 3, I have a function called adds20, and all it does is it takes in a num. On line 4, it takes that num, it adds 20 to it, and it returns that num. Okay? So on line 8 there, if I say let return num equals adds20 and I pass in my num, well, passing in my num there on line 8, that is the direct extension of this idea of us kind of making a copy or passing a value into it, right? Here on line 8, what I'm saying is I'm passing in my num into the function adds20, and once it goes into the function adds20, it becomes this parameter called num, called num on line 3, right? And now the question becomes, is num equal to, so after line 3 runs, right, we know that num is equal to 10, right, because that's what we passed in as my num, and we add 20 to num, so now num is 30. The question now is, okay, did we change the 10 that we see in my num, or did we change a copy of the 10 that we saw in my num? And so if we go back to the to our lesson about copying primitives, the idea is whenever you're passing a primitive back and forth, you're always passing along a copy of that value, not the original value itself, right? And so if I say that, then what I mean is on line 8 there, I take the value of my num, which is 10, and I pass in a copy of 10 into the adds20 function, right? So num now becomes this copy of 10. I add 10 to num, so now num is equal to 30, and then I return 30. Oops, sorry. But, but once again, just to keep note, right? I return 30. My return num is going to be equal to 30, but my num did not change because all of the work that I did to num in the adds20 function, that was on a copy of my num, not on the original value of 10, right? And so that just means my num, the value never really got changed. Let's contrast this with the complex values, right? Here I have my array. I set it equal to array with one element, the number 10. On line 3, I have a function called pushes20, which takes in an array, and all we do is we add 20 into the array, and we return the array. Okay. Notice on line 8, here I call pushes20, and I'm passing in my array. Now, if I pass in an array, an array is a complex data type. What I'm passing, remember, is no longer a copy of that value. it's the actual value or the actual reference to that value itself, right? And when I pass in my array into the pushes 20 function, it becomes the variable array on line 3 there. But now array is actually, it's not a copy of my array, it is my array. And so on line 4, when I push 20 into array, that's the same as pushing 20 into my array. And on line 5, when we return array, that's the same as pushing 20 into my array. And so therefore, when I console.log out my array or returned array for that matter, so the array that got returned on line 5 there, in both cases, I get the array with 2 elements, 10, 20, because on line 8, once again, when I pass in a complex value into that function, I'm not passing in a copy of that complex value. I am actually passing in that version of the complex value, or more specifically, I'm passing in the reference or the address of that complex value. Okay, any questions here before I wrap us up and kind of talk about the last concept of equality? Yes? No, so basically, slice, remember, is just a shortcut, and in the workshop, we actually had you build your own copy of slice, right? So the idea is if I want to create my own exact copy of an array, then slice works, but I can also just create a brand new empty array from scratch, go through the original array, and for each value, I copy it over one by one into the new array, right? So if my original array was an array, if my original array was an array with, let's say, 5 numbers into it, I can also create a brand new empty array, go through all 5 of the numbers in that original array, and move one of them over one by one into my new array. So I can also create it manually too, and that goes for objects as well. Yep, exactly. Yep. Cool. Any other questions? Awesome. Well, then just to wrap us up then, 2 more things we want to be aware of, right? One is, up until now, you've probably tried to use a triple equal sign, the equals to compare numbers, and it's worked perfectly. You've used it to compare strings, and it's also worked perfectly. But you might have also used it to compare complex values. You might try to use it to compare 2 objects, and you might have gotten unexpected results. And the reason why is because if I look at the examples on line 3 and 4 here, right? Notice how when we use triple equal signs on objects, what JavaScript is doing underneath the hood is that it's not comparing the values of those complex values. It's actually comparing the references to those complex values. And here on lines 3 and 4, I have 2 variables. Even though they happen to have the same value, they have different versions of those values. And so if I look at the reference for array 1, I know it will not be the same reference for array 2, and therefore array 1 does not equal array 2. Okay, and so as you use comparisons on complex values, just be very careful and keep in the back of your mind that, hey, what triple equal signs does for complex values is that I am not comparing the values, I am comparing the references, right? So unless those 2 are pointing to the same exact reference and therefore they're pointing to the same exact value, triple equal sign will not tell me that they are true. So here's an example now where array 1 is equal to this array 1, 2, 3, and I set it equal to that array. And now line 3, when I say let array 2 equal to array 1, JavaScript will say, oh great, what data type is array 1? It's a complex data type. Great, so let me copy the reference and let me set that reference, or let me set array 2 equal to that reference. And so because of that, array 1, if I compare to array 2, because they share the same reference, JavaScript is going to tell me they are true. The last thing we'll talk about here is the limitations of slice, right? So I guess, and maybe this also goes back to kind of it adds another layer of complexity to Jolene's question, which is, when I use slice, like, does it just work every time? And the answer is not exactly, right? So if I have an array with only primitive values, so numbers or strings or booleans inside of it, then slice will work perfectly every time. But in this case, on line 3 there, what if my array has both numbers, so primitives, and also complex values, right? I have a number 1, which is primitive, but I also have the array 2, 3. What happens when I use array1.slice? Well, what happens here when we use .slice is Slice is known as what we call a shallow copy, which means it only makes a copy at the topmost level. And so what does that mean? That means conceptually, when I do a slice version of array 1, JavaScript will say, here's a brand new array, okay? The first number I will copy over from the first element of array 1. It's a primitive, so when I copy it over, I am copying over its value, okay? For the second value, because it's an array 2, 3, it's actually a complex value, and so when I copy that over into the new array, I'm not going to copy over a copy of the value. I am only going to copy over the copy of its reference. And so therefore, if on line 6 or when I look at the new array that I just created, it looks the same as the original array. It's still the array was 1, and then space 2, 3. But notice how when I try to compare array 1 to array 2, they're fundamentally different arrays, right? Like they have different references. And on top of that, the other thing I want to point out is, so in the early example, because in this new array I copied over a reference to the array 2, 3. Notice how if I go into array 1, I go to the second element, which is the array of 2, 3, and I push in 4, and I console log out array 2 and the second element. Notice how that element has also changed now to have the value 2, 3, 4, and in fact the second element of array 1 has the same reference as the second element of array 2, right? So they're equal under the triple equal sign. And the reason why that's so important to know is that because here on line 8, even though I did a slice of array 1, the shallow copy means I only copy the topmost level of the array, and any complex values inside that array will be copied over, not by its value, but by its reference. And so in this case, we can say that array 2 and array 1 are not distinct from each other. They both still share a common connection still, because their second value, or because their second element, it is both of their second values share the same reference, and therefore they are still kind of tied to each other through that second value. Okay, so you'll do a problem on this in the workshop. So if it's a little bit confusing now, once you start the workshop, definitely let us know. But I think it's something that makes a bit more sense when you see it in practice, as opposed to just theory. And that's pretty much it for today. So any questions on anything I've talked about?